Hello, my name is Paulo Seleguim, and I'm a professor here at the University of São Paulo in Brazil. I'm recording this video to introduce you to my new book, Fundamentals of Aerospace Engineering. The book was published on Amazon in both Kindle and paperback versions, and available in both English and Portuguese. In broad terms, the content condenses several disciplines that I have been teaching here at the university, mainly for the aeronautical, mechanical, and mechatronics engineering courses over these last 35 years. I believe a good way to start this introduction is by reading the preface. So, let's get to it. I think it's more or less evident that I wanted to be an astronaut. I think every child of my generation did. Well, in fact, I had a friend who wanted to be a Formula One champion. Those were the days of the Apollo missions, of One Small Step for Man, and Emerson Fittipaldi. But of course it wasn't meant to be. So I took the closest path. I studied aeronautical engineering at the University of São Paulo here in Brazil, and today here I am with a book about rockets and space exploration. The motivation to explore space is ancestral, born of the same longing that led us to explore the African savannas 200,000 years ago, or embark on the great voyages of the 1400s. The 20th century marks the beginning of the exploration of our solar system, followed by a premature visit to the moon, and already in the 21st century, a modest permanent presence in orbit around the Earth. The great sea voyages were only made possible by the development of European caravels and carracks capable of crossing oceans and sustaining the lives of their crew during the journey. Similarly, to explore space, it will be necessary to develop spacecraft capable of crossing interplanetary distances and protecting us from the extreme conditions of the cosmos. The technical challenges that arise are equally extreme but not impossible to overcome. This book addresses exactly this problem, and particularly the knowledge network necessary for the development of orbital launch systems, among which rockets are the only viable solution at present. This can be observed, for instance, in the design of a rocket propulsion system, whose engineering involves thermodynamics, heat transfer, combustion, compressible flows, strength of materials, and, more recently, aeroacoustics and additive manufacturing technologies. I sought to structure this book in line with that vision, which meant developing the various topics and their synergy around specific applications or case studies. The inherent risk in this approach lies precisely in the author's limitation in terms of the latitude of his knowledge. However, I think you can agree, risk cannot be a deterrent for someone who once wanted to be an astronaut. Thus, the shoemaker decided to go beyond his shoes, dedicating Chapter 1 to recounting the history of space exploration and the development of orbital launch systems and rockets. There is much dream and fantasy in this topic, which is why authors like Jules Verne, H.G. Wells and Arthur Clarke, and many others make an appearance. But there are also doers like von Braun, Korolev, along with a darker side tied to the intercontinental ballistic missiles of the Cold War. The problem of orbital launch is addressed in Chapter 2, where some unconventional solutions are analyzed in detail, including the space cannon and the space elevator. Although dreamish, the formulation and conceptual design of these solutions are extremely interesting and illustrative of the technical challenges involved in placing an object into orbit, whether around the Earth or other planets and moons of our solar system. Self-propelled launchers are discussed at the end of the chapter, concluding with a comparative analysis between rockets and commercial air transport. Chapter 3 addresses the conceptual design of a rocket and its efficient operation. Specifically, The problem of optimal staging is formulated using two distinct approaches, enabling both the rapid attainment of practical results and also the derivation of fundamental theoretical principles. This analytical framework is validated by comparing its results with the configuration of the Saturn V rocket used in the Apollo missions. Finally, the problem of optimizing the rocket's launch trajectory is also analyzed through two possible formulations, the so-called quasi-flat Earth and the quasi-round Earth models, each progressively more realistic. Propulsion systems are studied in Chapter 4 with emphasis on the different configurations of thermochemical engines and the analysis of supersonic flow occurring in a convergent-divergent nozzle. The equations developed in this chapter are applied to the study of the engines of two legendary rockets, the V-2 of World War II and the Space Shuttle. Chapter 5 addresses what is perhaps the most dangerous phase of a launch mission: orbital re-entry and the necessary dissipation of mechanical energy through aerobraking. Aerodynamic heating is formulated, and the limiting temperatures associated with friction and flow stagnation are calculated. Three landing technologies are compared: parachutes, glided landings, and propulsive landings. The latter is examined in detail using the equations from Chapter 4, with a focus on minimizing the amount of propellant required. Although orbital launch and re-entry are the most critical and expensive phases of a mission, the ultimate goal often involves placing a satellite into geostationary orbit or, for example, inserting it into an interplanetary transfer trajectory. Chapter 6 focuses on orbital mechanics and demonstrates the practical applications of its equations by analyzing a range of case studies. We examined the Mars 2020 mission, which delivered the Perseverance and Ingenuity robotic probes to Mars. The complex aerobraking maneuvers performed by the Mars Reconnaissance Orbiter, and in greater detail the gravity assist maneuvers executed by Voyager 1 on its way out of the solar system en route to infinity and beyond.
I hope this book motivates you as much as I enjoyed its creation process.